Okay, we're finding the angle again in the second video, and we're going to do a problem solving application. We've got a question here, an example. We have a 2.8 metre long seesaw. Its maximum height is 1.1 metres off the ground. What angle, we've got to go to two decimal places, does the seesaw make with the ground? First step is to predict what do I think is going to be involved, what maths might be there, what might I be doing. Well, I reckon I might need to find a right angle triangle and use inverse trig because I'm finding an angle. Now we need to clarify. An important step in clarifying is to draw a diagram here so we can visualize it. So let's start with the ground, and it's a seesaw that's, if it's going to have a maximum height, well, that means it's going to be not going to be level, it's going to be like this. We've got the pivot bit in the middle, and the maximum height is going to be that end there. You know, when you've got a person heavier than you on the other end and you're stuck in the air, remember that? Well, that's your maximum height. Okay, and we've got the length of the seesaw we can put on there, it's 2.8 metres, and we've got that maximum height which is 1.1 metre above the ground, and we have to find the angle it makes with the ground. Well, there's the seesaw, there's the ground, so the angle is there. We're going to use our normal theta symbol for the angle. So basically we draw or visualize it. Drawing is good. The next step is to find the right angle triangle. So finding the right angle triangle, well, if we assume the ground is horizontal and flat, and this is vertically up as we know, we've got a right angle there, and assuming that we have a straight beam there on the seesaw, you can see the grey zone there makes a right angle triangle. So we have an angle, we have two given sides, we have to find the angle. Next we need to choose the trig ratio, the sine SOH, cos CAH, tan SOH, or some old hippies can't always hide their old age. So we need to start at the angle and look at what's involved. So we start at the angle given, that's theta. What do we have? Well, we have an opposite, that's O. We have a hypotenuse, that's H. What involves O and H together? This one. So we're going to use sine. So right down the rule we're going to use. Sine theta is opposite over hypotenuse. Now we get in and solve it, which means do the inverse trig. Okay, so let's start. We know we're going to use sine theta, so we start with that. Sine theta is opposite over hypotenuse. Well, we don't know what theta is, so we keep it as theta. Sine theta is opposite, which is 1.1 over hypotenuse 2.8. Now we have to apply the inverse trig. What we have to do is we want to find theta, so we have to undo the sine theta. So what we're really doing is inverse sining the sine, undoing it. So we've just got theta by itself, okay, which means on the other side we have to inverse sine. See how they're both in red? And I'm going to put brackets over the 1.1 over 2.8. These two here cancel each other out. Inverse sine of sine leaves just the angle. So what we have here is theta equals the inverse sine of 1.1 over 2.8, and you can use your calculator for that. And to two decimal places, as the question asks, we have 23.13 degrees. Now let's reflect. Does the answer make sense? Does it seem reasonable? 23.13 degrees does seem reasonable. It does make sense. Because if we look at the size of the angle from the rough sketch, the sketch is not to scale, but it's not too far off it either. And that angle is, well, it's not 45, it's nowhere near that, it's about half of that, and you know that 23.13 is roughly half of 45, so yeah, that seems reasonable, and we've got an angle and we've got to 2 decimal places, so answer seems right. Time to do some inverse trig.